my stoichiometry. We did all of that. Just, don't be flying up your nose at me. We did all of that just to get to this one little section. Okay? Stoichiometry is a method that allows us to calculate either the amount of products that we're going to get from a reaction, or if you have the number of products, you can backtrack to see how much reactant you have. Thank you. Okay, if we bring it home, let's say Ronnie, Mama sent you in the kitchen, tell her, go make some pasta. Okay, what do?
Make me some as well.
Yeah, you're gonna make some for everybody. But how are you gonna do it? What are you gonna do? What goes in the pot?
Water. Pasta.
Water. What else?
Pasta.
Pasta. What else?
Salt, I guess.
Salt. Right? So now, with this salt, how much salt are you gonna add? Are you going to add a teaspoon? Or are you gonna open the salt container and dump it in? Which one are you gonna do?
Small amount.
Small amount, right? So now, this is what stoichiometry is going to tell you, right? It's going to tell you how much do you need to get you that perfect al dente pasta, or are you going to get that salty mess that give high blood pressure and send you to the hospital, okay? So, some things that we need to know. We need to know something called mole ratio. Your mole ratio is telling you how much of each reactant you're going to need. So for example, you have, yes, you have a gallon of water to make your pasta. For a gallon of water, you're going to need a teaspoon of salt. For 10 gallons of water, you're going to need 10 teaspoons. If it's a 1-to-1 ratio. Now, your mole ratio for your chemical equations come from your reactants. Not your reactants, your coefficients. Your coefficients are going to tell you how much you need of each one to completely balance out the other one. Do we get that? Now, knowing how to recognize mole ratio is important. If we take, before you do your mole ratio, you must know how to balance your equation. If you do not know how to balance your equation, everything you do after that will be wrong. Okay? Now, we have our beautiful equation that I can have read in a sentence, please and thank you. Who's gonna do it? 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 Who's gonna do
So
it?
you said the subscript is the atoms, right?
Yes.
So you would say like 5 atoms.
No!
Just to say the full compound, like calcium.
Good job.
What's with the F?
Uh-huh.
How do you say it?
How do you say this?
Because it has an F too.
Yeah.
Calcium, phosphate. Fluoride.
There you go.
So you just add on the last part.
Okay? So now, where does my mole ratio come from? My coefficient. Good. Now, Mohammed, since you started, can you finish my sentence, please, and thank you?
Yes, 1 mole calcium phosphate chloride react with 5 mole sulfuric acid. We produce 3 mole phosphoric acid, and 1 mole hydrochloride, and 5 mole calcium.
Very good. Right? Yeah, he did. That's good. Well, hydrogen fluoride or hydrofluoric acid?
HF.
HF.
So, whatever hydrogen is with another element, it,
If it's a halogen,
or if the halogen turns into acid.
yes.
Can we say hydrogen sulfate or no?
Where you say hydrogen sulfate?
Oh shit.
Stop cussing!
Sorry, my phone does.
Where you say hydrogen phosphate?
H2SO.
Sulfuric acid.
Sulfuric acid, always. Okay? So, in order to figure out mole ratio comes with reactant to reactant, reactant to product, and product to product. Right? So now, who's going to give me my first batch? I want to know the mole ratios for reactant to reactant.
Okay. 1, 5, 1,
One.
2.
No. You tell me 1 mole of calcium phosphate fluoride per
Or 5 mole of sulfuric acid.
sulfuric acid. Very good. That's the first one. Okay? Now, we're going to go reactant to products. Bim, continue for me.
1 mole of calcium phosphate fluoride
Per,
for 3 moles of phosphoric acid.
again,
1 mole of calcium phosphate fluoride for 3 moles. Oh, hydrofluoric acid.
how many?
1 mole of hydrofluoric acid.
Back again.
1 mole of calcium phosphate fluoride for 5 mole of calcium sulfate.
Back again.
5 mole of sulfuric acid for 3 mole of phosphoric acid.
Back again.
5 mole of sulfuric acid for 1 mole of hydrofluoric acid.
Back again.
5 mole of sulfuric acid for 5 mole of calcium sulfate.
Now we're going to do product to product. Keep going.
Alright, 3 mole of phosphoric acid for 1 mole of hydrofluoric acid. 3 mole of phosphoric acid for 5 mole of calcium sulfate. 1 mole of hydrofluoric acid for 5 mole of calcium sulfate.
And there you have it. These are half of your mole ratios. What would the other half be?
Product to react.
Product to
No.
product.
Just from these. Just from looking at these. What can you tell me would be the other half? There is 2, 4, 6, 8, 10 here. There are 10 more. What would they be? If you flip these.
Yeah, you go opposite.
No, not opposite. You can just take these in itself and flip them. If each of these are flipped, you're going to have, that's how many conversion factors you have. These are all, your multimole ratios are simply conversion factors. If I were to give you my question in calcium phosphate fluoride and ask for my answer in hydrofluoric acid, which one do I use? Which is that one? The third one. Do I keep it this way? Why do you flip it? Because I want the
Hydrofluoric acid.
hydrofluoric acid. I want my HF. So my HF must be on top, so this must be flipped.
So you'll give it to us that way and then we have to.
No,
Wait, so
I'll give you the equation,
Oh,
and you
okay.
can figure out what you need to get.
So but ask the question again?
If I give you my question in calcium phosphate fluoride, I want my answer in hydrofluoric acid. Which one do you use?
Oh, okay.
Wait,
Yes.
so it's the first the first reactant
Yes,
to the other reactant, that's
yes,
one.
that's one.
And then the first reactant
Yes.
to the first product,
Yes,
that's two.
yes.
And then first reactant to the last product,
Second,
second product.
yes, that's three.
And then the second reactant to the first product.
No,
Oh,
you first reactant to the last product.
yeah.
You didn't say that.
I didn't, you said second. I said
To the
first.
second product, though you can't just leave out one.
Oh, could it hydrofluoric?
Cousin!
I said cool. I said could it hydrofluoric? Cool. Look at. Translate.
I'm lucky. Okay? Do we get that? Yes.
So Professor, so you asking that if you give us the calcium phosphate chloride and ask for the hydrogen fluoride, so that's the, we only focus on the calcium phosphate and hydrogen fluoride.
Yes.
We didn't talk about the.
You don't need to know anything else. Okay? You focus, the question will give you two things. Either a reactant and a product, a reactant and a reactant, a product and a product, or so forth. You only focus on those two things. You only write the mole ratio for those two things. You don't need to worry about everything else. Yes?
But figure it out, we have to figure all of them.
No, you don't.
But Professor, if you're gonna ask, it's gonna be two answers, right? Or
One answer.
Only one.
Only
when
one answer.
when it's coming on the top.
Yes.
Can you have an example for
Of
that?
course, we have tons of examples, but we need to get through some stuff before we get to examples. Okay? Alright, here's another one. What are my mole ratios here?
And that one.
Nah, don't tell me end that one so since you started up, you gonna finish it. Go ahead.
What is 1 mole?
Uh-huh.
1 mole of nitrogen gas.
Very
At
good.
the bottom. Plus 3 moles of hydrogen.
No, I'm not asking you to read
Oh,
it
okay,
in a
okay, so
sentence.
let's do the thingamajig.
Right.
Okay, nitrogen gas.
How much? You
1
got it?
mole of nitrogen gas. Do I do over? How do I say per
Per.
3 moles of hydrogen gas.
Uh-huh.
Then it's do you do that?
Yes.
That? Okay.
Yes.
Then it is 1 mole of nitrogen gas per 2 moles of what?
That's ammonia.
Ammonia.
The ammonia.
Ammonia.
That's it. That's it.
Okay. Okay. And then you start with 3 moles of hydrogen gas per 2 moles of ammonia.
Very good.
Okay.
It's gasoline or hydrocarbon?
Gasoline, it's a mixture of different hydrocarbons, which is why there's like a tiny little explosion in your piston that gets your car to move.
So gasoline plus O2. That's still technically a combustion reaction.
That is a combustion reaction.
Or just
You ever see, the movies where if the woman is gone and she do so and she does gasoline all over the house and she just flick out the matches? Boom! Oh! You see? Oh! Did you?
What are you trying to say?
I want to know. I want to know. You know what just happened, Mr. Thompson?
the surface.
No, you have just received your first snatch. You have just received your first snatch. That's what you get. You know what a snatch is. Don't try that. All right, bet. Let's figure out what snatch is from now. Okay? So, technically, as your teacher, when you do things, I can't do anything to you. But as soon as August 5th hits, I am no longer your teacher. Snatch!
You're putting the bullet on.
Yes! See how
I'm gonna try to help with each of his grabbing one.
Okay, my lovely question, my equation. Okay? Now, you ready? We got this? Set it up? Alright. Calculate the number of moles of phosphoric acid formed by the reaction of 10 moles of sulfuric acid.
Wait, hold on.
No. Take it one step at a time. Okay? Remember, before we get there, what's our setup? What is our setup?
That's what we
Moles
keep
of water.
No.
Moles on.
What goes outside?
No,
No, we
no.
know.
The molecule.
No.
What we
No.
have. Let's give him.
You're giving. Don't try to steal from Rana.
I finished the end.
Yeah, all right. You're given. All right. Then you have your brackets with your conversion factor on the inside. What's on top?
What you want?
What you want? What's on the bottom?
To cancel out.
What's given? Okay? So here again. Calculate the number of moles of phosphoric acid formed by the reaction of 10 moles of sulfuric acid. What is your given?
Them two.
Can we with them two? It's not them two.
Phosphoric acid.
No,
Wait.
you're given
10 moles.
10 moles of sulfuric acid. That goes on the outside. So now what goes inside your brackets?
The ratio.
The ratio of phosphoric acid to sulfuric acid. Which one goes on top? Phosphoric acid. So what's the mole ratio there?
3/5.
No, don't tell me no 3/5.
5 over.
3
Moles.
moles of phosphoric acid per
5 mole of sulfuric
5 moles of sulfuric acid.
So it's going
Wait.
to be more.
What's going on, Mr. Craxton?
So we have 10 moles of sulfuric acid, brackets. Top goes what again?
3 mole of
3 moles
phosphoric acid
phosphoric acid,
over 5 mole
5 moles of
sulfuric acid.
sulfuric acid. What do we do next?
Cancel.
Cancel out.
Yeah, so 6.
Then we multiply across, divide by the bottom.
Yeah.
It's the same thing that we've been doing.
You put the 3
It's
there too?
easy.
You took the
So
3?
that.
What 3?
You put 3 on top or just all?
The 3.
Or just phosphoric acid?
3 moles. You gotta give me the moles too.
There's a question.
Do we put the 3 moles of the H3PO?
Don't
The hydrochloric acid.
Thank you. Did you say hydro?
No, I said phosphoric acid.
Oh, thank you. So what's my answer here?
6 moles. 3 moles.
Phosphoric.
6.
3. I hit 3 and I hit 6.
It's 6
moles.
6 moles.
6 moles of
Phosphoric acid.
I apologize.
React with 10 moles.
That's what I got too. All right. You get that?
Yeah.
Good. All
Yeah.
right. Let's do another one then.
It's not that bad.
It's not that bad. It's not. Okay? And let's just stop and take a moment. That Monique just said it was not that bad. Let's just point that out there. I need everybody to understand what just happened right there. Okay? So, calculate the number of moles of calcium sulfate formed by the reaction of 10 moles of calcium phosphate fluoride.
15.
I don't know how you got that.
10 moles of calcium phosphoric acid.
So 10 moles of calcium phosphate fluoride,
5 mole of calcium sulfate
5 moles of calcium sulfate,
over 1 mole of calcium phosphate fluoride.
1 mole of calcium phosphate fluoride. What do you do next? Cross it out. Multiply across, divide by the bottom, what do we get? Yes, you are.
I'm just going to show everything, right? Like this.
Yes, you must show me everything. We got that? You good? Got it? Now,
Whole mass.
mole to mass.
Mole to gram.
That means, yes, I give you my question in moles, I want my answer in mass. How do we go from moles to mass? What do we need?
You need the
Atomic mass.
moles.
Well, what do you need? What goes in the brackets? What do we need?
Gram.
You need moles on top.
Gram.
Moles on top,
No.
grams on.
What is that called? M. The molar mass. Well, I'm gonna need you to be louder and prouder. We got all these people. I can't hear everything.
You can hear?
Okay. Ooh.
See, you got snatched.
Yeah, you see how he just trying to come at me, right? I'm just saying, point that out, Mohammed. Well, no, you have a history of snatching, okay? All right, let's go. Same equation, the invariant yet. Calculate the number of grams of sulfuric acid formed from the reaction of 12 moles of phosphoric acid.
I got it.
What you got? Let me hear you. Bust it out.
So on the outside, we would put 3 moles,
12, ain't it 12?
12 moles of phosphoric acid, multiplied by the molar mass of sulfuric acid.
Don't you put what's given?
On top, I'm sorry.
No,
So 1.
no.
5 mole of sulfuric acid.
How you get that? What do you need to do? At this point, what do you need to do?
Cancel out.
You need to cancel out this. The only way to cancel out your phosphoric acid is to do your
Oh no, okay, multiple
the
ratio.
multiple ratio. What's that? What goes up top?
High mole of sulfuric acid.
5 moles
Sulfuric acid.
sulfuric acid,
Divided by
3 moles of phosphoric. Cancel this out. Multiply across, divide by the bottom. What do we get?
20 moles.
20 moles of
Sulfuric acid.
sulfuric acid. So you take this moles now,
Convert that to grams.
convert this to grams. What do we need in order to do that?
Okay, now
Your molar mass. What's your molar mass of sulfuric acid?
32.
102.
No, 32. 64 plus 22 plus
32 is for the
98 grams.
sulfur.
Where does that go?
64
So 98 grams
of sulfuric acid.
sulfuric acid.
Where you get that 98 from?
So what are my atoms involved here?
The hydrogen,
Hydrogen,
sulfur,
sulfur,
oxygen.
oxygen. What's the molar mass here?
1.
Wait, how many do you have here?
1. 2. So 2 times.
Here,
1.
here.
4.
How much molar mass?
4 times 1. 2 times 1, I should say 2. 2 times 1 is 2.
You haven't been on the table, did you not?
I mean, are we gonna have it?
Ain't it 2 times 1? 2 times
What do the?
Wait,
You put 5 on the bottom? Wait, is that what?
I know, but I'm saying for number 1, how you get 1? 2 times 1 or 1?
This is how many atoms there are,
Oh, okay, you didn't do the
and
times.
this is your molar mass.
Okay.
So what's the molar mass of sulfur?
Full of
3 significant figures.
32, 1, yeah.
Minus 2.
Grams per mole.
6.
So you gotta show this thing.
Oh wait, this is,
Wait, so 2 times 1 is 1?
It's drop two.
oh Lord, I lied.
Oh, man, no something slow about Jesus.
So 64 plus 62.1 plus 2 is 98.1.
Okay.
Yes,
But you said two significant. So we're supposed to.
I said 3 significant, I never said 2 significant figures.
What if it's in the.
Quick, she had her hands up.
When did you say that?
Say what?
So go to three significant figures.
I asked for 3 significant figures here.
Just now?
Yeah.
Oh. Okay, what if in the example it's two significant figures?
Again, that does not count when you're calculating your
Okay, just the.
molar mass, just your starting point and your ending point. Alright, so what goes on here?
1 mole of sulfuric acid.
1 mole. So what do we do next?
Cross out, multiply.
Cancel out your moles, multiply cross, divide by the bottom, what do we get?
1960.2.
1960
0.2.
minus 2.
0.2 gram of sulfuric acid.
No.
That's what I got.
So I have a question.
Yes.
Professor.
Go ahead.
So I didn't do it to the three significant figures. I just did it according to the amount of significant figures it should have had.
Okay, so what did you get?
1961.54, and I don't know to what.
So, alright, so the only way that you would get that is if you use this here, the 32.1. That's what you use?
No, I used this whole.
Yeah. Well, okay, so you won't have to worry about that because I'm going to give to you the number that I want you to use. Right? So you don't have to worry about digging up the periodic table to find the molar mass.
Oh,
The
so
molar
you
mass
give
will
us
be-
what it is for each one.
Yes, and you have to then figure out what the formula is to get your molar mass.
So then you will say, so the for S you will tell us that you want 32.1. So that
Yes.
32.1 will be there.
Yes.
Okay, quick. Okay.
How can you divide it by 1 mole of sulfuric acid and not 3? No, 5.
Because this right here is your molar mass. Your molar mass is not 3 moles. Your molar mass is 1 mole.
You're right.
In here, or let me see.
Right? Did we get that so far?
How do we know how many significant, non-significant figures we have to use?
This will go back to, with these, it ultimately goes back to every time you're trying to figure out your significant figures, it will always go back to your question itself. But in questions like these, you're not going to get anything radical to where you have 7 digits in your answer. So you and I are supposed to get the same number at the end. Right?
When I did that, I got 1962.
Because you use a
No,
different
doing that.
value here.
Wait.
Because you use this, right?
Yeah.
I use that.
Oh, 98.
Right. Okay? Yeah. Alright, how do you get 2 significant figures here? What would it be?
2.0 multiplied by 2
Wait. But it gives you like a whole number. There isn't like extras, so that's why there's nothing to. When you multiply those, this is what you get here. So just look.
No. That's not what she's asking.
What she asked.
She's asking if you have this answer here,
Mhm.
and I tell you that I want this in 2 significant figures, what would the answer be?
1.9.
No.
2.0.
You would have to put it in scientific notation. So what would it, 2.0 times 10 to the power of 3. There you go.
What
Is
are
it
we
gonna be a
wait,
right answer if I gonna live like that?
Yes.
I'm lost. As to what?
So this here,
Yeah.
written in 2 significant figures, what would it be?
1.9.
Oh, 1960?
No, 2.0. 2.0.
That's wrong. If you just stop it at 2.0, that is wrong.
Remember the bar.
How do you get
There you go. You must tell me to the 10th power of 3?
How is it 2 point?
So where would you put your decimal point?
After the first significant figure.
So between what and what?
Between 1 and 9.
Between 1 and 9.
Yeah.
I want 2 significant figures. So if you put in your decimal point there, where exactly are you counting your 2 significant figures from? Between where and where? Where are you drawing your line? Between where and where? I want 2 significant figures. Where would you draw your line? After your 9. So in between your 9 and your 6. Now you look at your neighbor.
It's bigger than 5.
It's bigger than 5, so therefore you round up.
Okay.
Alright, so let's try another one. Now we're taking a different equation now. Let's see if we can apply what we've learned. Calculate the number of grams of hydrogen gas required to form 12 moles of ammonia.
So, mass to mole and mole to mole?
Huh? No. Mole to mole and mole to mass. You're on experiment 4, right?
Yeah.
Y'all gonna do the experiment. Can't, sir? No, sir.
This with the crucible, right?
Yep.
You gonna be tight.
I'm gonna be tired. I'm gonna be sitting down. Y'all murder my crucible. Ooh! Murder my crucible. So what do we have?
288 grams.
288 grams?
Where?
I don't know.
Whoa, wait, I'm like, that's
What did you get?
36. I don't
You
know.
got 36 grams? Let's set it up.
Hold up. I'm the brightest, so I don't know.
Alright, so where we start? What goes on that side? 12 moles of ammonia. Three moles hydrogen gas. Cancel out ammonia, multiply across divide by the bottom. What do we get? Take your 18 moles of hydrogen gas. To where?
Grams and on top.
2 grams of hydrogen gas.
And 1 mole.
1 mole. Cancel that, multiply across divide by the bottom. You get minus 2.
6 grams of hydrogen gas. Same thing.
No same thing. Watch me give you a big fat 0.
I have wrote it though.
That's what I got you. Do we get that? Alright.
If I didn't put the H2, that's wrong.
Yes.
Not even half?
Not even have.
Harsh.
Alright. So now we have mass to mole calculation. I give you my answer. My question, sorry, in mass. I want my answer in moles. So what we just did, we did multiple conversion, then mass. Now we need to do mass, then your multiple conversion. Alright? So here, calculate the number of moles of calcium phosphate fluoride that reacts with 588 grams of sulfuric acid.
Wait, so the last question was from
Moles to mass.
moles.
And now we have mass to moles. What do we have? What do we do? How do we get it done? Huh?
We convert everything in grams.
Convert to grams first. So you have 500 and you convert to grams?
Like 500 grams.
You convert to moles.
Oh,
What is that, calcium phosphate fluoride?
Yes.
Calcium phosphate fluoride?
At least you give us the mole mass.
I know, right? I'm so nice.
Are you gonna do it like that all the time?
Child.
No.
Oh, you got jokes today, huh?
I think I'm gonna snatch you now. I'm gonna snatch you. Alright, so start with giving, right?
Mm-hmm. That's what you got?
that's I got. I decided wrong.
You got that too, did you have?
1.2.
Yeah.
Do you just flip or something down here?
What do you mean?
Like how, that two over there, that's the mole mass, right?
Yes.
But then for this one, we just flip it? Like put the mole mass at the bottom? Okay, because that's what we're trying to get to.
Right.
He already has 5 moles. So you need
So that's
one extra
six.
mole. To complete the equation, right?
1.9.
So
Are you
6 divided by 5 is
You
1.
still, you missing something,
588 grams
right?
times 1 mole
Right?
divided by 98.
Right? That gives you
6 moles.
of,
That's not pretty good.
The calcium.
no.
Sulfuric acid.
See, this is the problem that I have with you since before. You leave out your units, and therefore you don't know what your answer is in. Start over and put in the proper units. What'd you get?
1.2.
What'd you get? What? I would need you not to be leaving your glasses no way. How you walk out the house with no eyes?
One more than a year.
What'd you get, baby?
Let's convert it to mole.
Oh, I'm sorry.
You're halfway there. You're halfway there. You're not there yet.
I need to do the second.
So I got 1.2 also. Okay? Don't stop at this section. Once you convert your grams to moles, you must then do your multimole ratio. Do we get that?
Wait, no, that last step. What?
So you convert your grams to moles. Then you do your multimole ratio to get rid of your sulfuric acid to end up with what you want.
Like, in the bracket, I did the 5 times 98. Is it problem or not?
Don't do that.
Wait, so but can you do it out on the board? Because that way it's confusing.
Don't.
Don't just do that.
Don't do that, because if you mess up the positions, you can get it wrong.
Okay.
If you keep everything in order, that's fine. But if you get something that's more complicated, like you need to do 3 of these conversions, you have them spaced out so this way you don't mess them up. You keep them in order. Tell me, money.
Can you do, because,
Wanna do it?
yeah, please, so I can see it out.
But shouldn't you have done this though?
I
Shouldn't you
did,
have
I
said
did,
it?
did up to 6, but I don't know what's done after that.
But you did it the other way.
Yeah, but
You-
then now it's opposite. I'm confused.
This,
Do I put that
What
6
goes in front?
outside?
yeah, that's your new outside.
Yeah, I put the 6 more.
So tell me from the start, what we come up with?
588 grams
588 grams
of sulfuric acid,
sulfuric.
acid.
What's
Then
in here?
1 mole up top. Oh, sorry, 1 mole up top, and then 1 gram of. Oh no, 98 gram of the sulfuric acid. And cancel that thingy out.
Cancel that out, multiply by the bottom, what do you get?
6. I got 6.
Minus 2.
6. Oh, sorry, 6. 6 moles. But I don't know what to put after that. What I'm putting. Per gram?
You cancel out the grams, not the
Oh,
sulfuric acid,
okay,
sorry.
okay. So that's how I was confused. I forgot.
So you have the sulfuric acid comes over.
Okay. So we cancel out the grams, not the thingamajig.
Yes.
Alright.
So now you take, this is your new thing. 6 moles sulfuric acid.
Oh, see now that's how I was confused because I didn't. Now I know what to put at the bottom after
Right.
that. Now, okay.
So now what goes in here?
The H is 5. The
Where?
5 at the bottom because we're trying to cancel that out.
5 moles sulfuric acid. Up top,
We're trying to find.
1 mole.
Oh, okay.
Now you cancel out your sulfuric acid. Multiply across the bottom by the bottom, you get 1.2.
Okay.
You get it?
Yes. 6
Good.
divided by.
Take another one. Calculate the number of moles of ammonia formed by the reaction of 112 grams of nitrogen gas.
SN2. Hydrogen.
Yes.
4 grams of sugar.
Yes.
Eight.
8-0.
Eight only.
Just 8.
8 more. 8 more
Eight
ammonia.
Wait, what?
I don't know.
Hold on. Yeah.
Are we in a consensus? 8 moles of ammonia, that's what I got.